All right. Hey, physics humans. So, this is part two of determining the relationship between the energies. And last time I left you with the challenge of figuring out what was going on at three. So, quick review. This is E1. This is the energy at 1, and this is point 1. This is E2. This is the energy at 2 and point 2. And this is E3. This is the energy. This is point 3 and the energy at 3. So one thing we know is the energy at 1 is equal to the energy at 2. We also know that the energy at 2 is equal to the energy at 3. Right? These questions right now, particularly in this chapter, I'll assume that this is a closed system. So none of the energy is being added later, and there's no energy that's being destroyed. So all this energy here that the cart has at the bottom of the hill is going to help the energy, right, get up to the top of the hill. So if you've ever seen Ninja Warrior, they have this great warp wall where you have to start at the bottom and run up and get to the top of the wall. And everybody wants to jog and then jump. And in fact, the best thing you can do is run as fast as you can into the wall. And they say, lift your chest up so that your body is going up and you're transferring your energy up, but you actually run into the wall as fast as you can. The faster you can actually run, the easier it is to actually get to the top of the warp wall. And that's on physics. That's on the fact that this velocity right here, all of this kinetic energy right here, is going to become how much height you actually get. That's the math. And so while you can jump, it's actually much more helpful to be going faster and to just try and transfer all of the energy you have from going faster into potential energy of height. Right? It's much easier to make that transformation. You have to be going faster. The faster you go, the more energy you go here, the more likely it is you're going to actually get to the top of the warped wall. So there you go. Next time you need to get somewhere high, run faster. And that's why they make basketball players run sprints, among other reasons. So let's see if you came up with a correct relationship here at 3, and as well as 2. So here at 3, you should see that there is gravitational potential energy. So hopefully you wrote that there is GP. Wow, that G is awesome. Hopefully you wrote that there is GPE here, and labeled it GPE3, right? Because this gravitational potential energy is different from this one. This height is different, so the gravitational potential energies are different. And here, it has gravitational potential energy. Is there kinetic energy? Does this car have kinetic energy? And it turns out that here at point 3, the velocity is 0, so there is no kinetic energy. We already talked about the fact that the energy at 2 is, in fact, all kinetic. So the energy at 2 is just KE2. So if we were trying to describe the relationship between the energy at 2 and the energy at 3, we would say, mathematically, the energy at 2 has to equal, that equals the energy at 3. That means that the energy at 2, well, we only have this KE. So that means the energy at 2 is just going to be this Ke2. Right? And mathematically, that's going to be equal to the energy at 3. So here at 3, we only have this GPE. So the Ke at 2 is going to be the GPE at 3. So hopefully you got this right and also learned more about how to jump high. Right? Turns out physics is life, and it's everywhere. Go out and practice making these relationships and figuring out when you need to add together both types of energy, when you have just one type of energy, which energy is equal to which. So I have a question for you. Is the energy at 1 equal to the energy at 3? Could we say E1 equals E3? I hope you said yeah, right? All this energy is being conserved. This is all a closed system, right? So if this energy equals this energy, right, if E1 equaled E2 in the previous example, and E2 equals E3, E1 is also going to equal E3. So go forth, practice. The more you do, the easier it'll get. You got this, guys.